Hi, everyone. You're listening to episode 668 of People Behind the Science. Today, we are rebroadcasting our interview with the wonderful Dr. Gail Ashley, originally released on July 11th of 2016. Listeners, Gail is a pioneering woman in the field of geology and sedimentology. She was the second woman in history to serve as president of the Geological Society of America, and she's received numerous awards and honors and served in a variety of other leadership roles in the field. Her research is focused on a past time period of rapid climate change known as the Quaternary epoch, and she works with paleoanthropologists to provide context about how early humans lived, what their climate was like, what they likely ate, and where they sourced their water. And in our interview, Gail shares more about her research and her life as a scientist. So sit back, relax, and enjoy this episode of People Behind the Science.
Every day, discoveries are made that will change our understanding of the world around us. Dr. Marie McNeely is here to bring you the brilliant minds who are making these discoveries so they can share their incredible stories and take you on an amazing journey. Welcome to People Behind the Science.
Hello, everyone, and welcome to another episode of People Behind the Science. Today, I am thrilled to introduce you all to Dr. Gail Ashley. So, Gail, thank you so much for joining us today on the show. How are you?
I'm fine. Thank you.
Wonderful. Well, we are delighted to have you with us today, and I'm excited to introduce you to our listeners. So, listeners, Gail is a distinguished professor in the Department of Earth and Planetary Sciences at Rutgers University. She received her bachelor's and master's degrees in geology from the University of Massachusetts, and she completed her Ph.D. at the University of British Columbia. Now, after receiving her Ph.D., Gail accepted a faculty position at Rutgers, and she has been a faculty member there for 39 years. And during that time, she has received many awards and honors, including the Geological Society of America's Laurence Sloss Award for her lifetime achievements in geology, as well as an Outstanding Teacher Award from the Association of Women Geoscientists. Gail has also served as president of the Geological Society of America, president of the Society of Economic and Petroleum Mineralogists, as well as president of the American Geosciences Institute. And listeners, Gail is here with us today to talk about her experiences in life and science. So today, Gail, we are excited to learn a little bit more about you and your science. So first, we want to start about your life outside of science. So can you tell us how you spend your time when you're not hard at work?
Well, I don't have a lot of time, but one of my favorite hobbies is actually cutting and storing firewood. I have a small property here in New Jersey with woods on it and have a wood-burning stove during the winter. So one of my hobbies, oddly enough, is cutting trees, splitting wood, and stacking wood. I find it very relaxing.
Well, I think that's phenomenal exercise as well.
Yes.
I know I've tried cutting wood myself. My father used to have woods behind his house, and we'd kind of make bonfires in the back, and he had a wood-burning stove as well. And it is not easy, I must say. No. So I admire that.
I have a feeling of accomplishment of getting things stacked up. So
absolutely. Well, Gail, wonderful to get a little bit of insight into your life outside of science and some of the things you like to do with your free time. But now I do want to talk about your science next. So I know this is something that eats up a lot of time in the life of a scientist, and they're excited to do it. So can you give us the high-level view of what you do at work and how you would describe it to someone who's not familiar with your field?
Well, I work in East Africa, where humans are known to have originated, and I'm working with paleoanthropologists, and I'm with them as they uncover records of early humans. But my role as a geologist is to think about the environment that these hominins originated in, what kind of climate, what they might have eaten, and particularly what their sources of water were, to help provide a context of the environment in which they lived and thrived on the landscape and ultimately evolved.
Well, this is really cool. I love this idea of you working with your collaborators to kind of rebuild a picture of what the world was like back then and how people were living. So we'll chat more about the projects that you've got going on in a little bit. But I do want to talk about motivation. You mentioned that you don't have a lot of free time. You spend a lot of time doing your work. And I'm always curious to hear about what motivates scientists. So do you have a favorite quote or maybe a saying that keeps you going when you're super busy?
Well, this is a bit silly for someone my age, but it's pull up your socks and get on with your life.
I like it. So can you tell us, is this something that you have in your mind in the morning as you're getting ready for work?
Sometimes when research is getting you down or just life in general, realize that there's always a bright spot out there. So when I've had bad times in my life, I put that up on my bathroom mirror. pull up your socks and get on with your life.
I like it. A daily reminder to just keep going.
Right.
Well, that's awesome. Well, Gail, now we've heard a little bit about what motivates you, what keeps you going, but I want to hear it next about some of these people who've had a big impact on you. I think as a scientist, you have so many mentors and role models and people that you look up to and work with throughout your career. Are there ones that really stick out in your mind as people who had a big impact on you or maybe were really strong role models? Can you share these?
In fact, the first role model that I had was not a scientist actually at all. She was an artist, and she lived next door to me as I was growing up as a teenager. This was back in the 50s when women were mainly housewives, and my mom was one. But my next door neighbor was an artist, and she pursued her artistic interests. She took off in the summer and went to Vermont and did painting there. She ran a small art school in her house. So she pursued her dreams and pursued her interests despite what the neighbors thought or what people around her thought. I didn't realize it at the time, but she was a role model for me to be able to pursue what I really wanted to do.
That is awesome to have someone like that you can look up to who, you're absolutely right, is pursuing their passion, pursuing their dream. I must ask, Gail, did you dabble in art yourself, having this person to look up to?
No, my son's an artist. It sort of skipped my generation, I think, but I appreciate art and I understand the artists from their viewpoint. So she was very important to me. I also had some male geologists who were mentors to me. Because there were no women at the time when I was becoming interested in geology, there just simply weren't any women in the faculties, or I was the only student as well. So I didn't have any women role models, but I did have several males who were at various times in my life were encouraging to me and acted as role models at different times and under different circumstances. But they're the ones that kept me going during times when I was having a change of thought.
Absolutely. Now, you mentioned that there were times where you were the only female student, perhaps the only faculty in your department. I understand even at Rutgers, you were the only female professor in your department for many years. Was this a challenge for you, or were there certain things that you found frustrating in this role?
For the first 20 years at Rutgers, I was the only female. I found it challenging, not so much that I had undue pressure on me, except to participate in a lot of committees, to be actively involved in a lot of things. Because I was the only woman, they felt obligated to make sure that the committees were balanced. And so I was asked to be on load.
Everything, yeah.
Right. And at the time, I didn't know enough to say no. And so I basically suffered from overwork. But that was the situation and just a lack of appreciation about what to do about it. So overall, it was something that I got used to. But now in the last 20 years, as we've added faculty into the department, it's been amazing, a change, and I think a great change in terms of the diversity and just having a much more balanced presence in the faculty.
Certainly. And I'm sure you've been able to serve as a role model and a mentor to a lot of these then young faculty coming into the department, which is phenomenal. So now, can you tell us a little bit about where your journey in science began? Can you take us all the way back to the beginning, Gail, and tell us about what first got you excited about science?
Well, the first time I even realized the term science or knew what science was in the 8th grade. I'm not sure why I wasn't aware of it before. It was probably given another name in my classes. But in 8th grade, we actually had a course called science. And I took it and I knew it was my favorite class and I just loved it. And every single topic was interesting to me. And that was, I think I was about 14 or so. And about that same time, my next door neighbors again, and this is not the artist, but it's her husband, happened to be a geologist. He was a professor at a local university and he was next door and I was always over at their house. And I started to ask him he would go off in the summer and I would ask him about what he was doing away for the summer. And he explained what he was doing. And it sounded absolutely fascinating because my father was a pharmacist, worked in a drugstore and put pills in bottles. And
not as glamorous as traveling over the summer. Yeah,
not at all. So this professor went off to Alaska every summer and he would come back with pictures and souvenirs and so on. And so with his guidance, he gave me some books to read. And so starting around age 14, I read geology textbooks and he would answer my questions if I had them about big words or difficult concepts. So he's the one that sort of got me started. And I had that to go along with through high school until I got to college. In high school, I was deflected from taking earth science because I was told that geology was not a real science, that if I was going to be college track, I should be taking chemistry, physics, and math.
Really?
Yes, I think that geology often does not have the full respect that it deserves, or at least back then it didn't. And so I waited until I went to university, and then I started to major in geology there. And at the same time, joined an outdoor club and started to do hiking and mountain climbing and spelunking and rock climbing and all those outdoor activities, which I had never been exposed to before, never had the opportunity. And so the combination of these outdoor activities and the geology very much clinched the deal for me in terms of what I wanted to do with my life. So that was how it all began.
That's a wonderful story. Really interesting to hear about these next door neighbors who ended up being really, really important role models throughout your life, both the artist and the geologist. So now tell us a little bit about what took you from this curious student starting to pursue geology in university. How did you know you wanted to go on to graduate school? How did you get to this track of being a professor?
Well, I had a slight diversion from my career goals. I became married and had children, and those family interests sort of took priority. And I traveled with my husband to his job where he was hired. And so for several years, at least 5 or 6 years, I was tied up and focused on family and young children. And then was able, once we relocated again and moved again, was able to think about going to graduate school. And so I applied and was accepted and worked on my master's degree over about a 6-year period or 7-year period. Slowly, because I had young children that were in daycare and school and so on. So I finished my master's degree. There I was with a master's degree and 2 young children, and realizing that it was going to be a major step to pursue what I wanted to do, which was to become a researcher and to go to the university. So I thought about it for a while. My husband was willing to relocate, so I made the plunge and realized that I needed to do it then because I was not getting any younger, and I was 32 at the time, actually. So I went to the University of British Columbia in Canada and did my Ph.D. there and finished when I was 36. So I was quite old at that time to enter the field, but not too old. And I received an offer at the University of Rutgers to become a professor with tenure track. So that was a happy ending there. But then the story, of course, just begins in terms of getting tenure. It's a lot of work involved. But that's how I got to my position.
Absolutely. And I think you brought up a lot of really great points, Gail, in sharing the story. And I think this idea of balancing your family life with your scientific career goals is a challenge for a lot of people out there who might be not sure when to start a family or at what point in their career they should make these decisions. So do you have any advice kind of looking back on how things worked out for you that you could share with our listeners today?
Well, the situation now is quite different. Most folks can plan their families. Back when I was younger, that was not quite the option. It wasn't quite as available to us at that point. And so I found myself with a family before I really had much planning involved. But nowadays, students can make a plan. And the universities are becoming a little more receptive to having a family life. Not all schools have gotten to that point yet, as much as we would like. But there are programs in most universities that will allow faculty to take time off, parental leave, and that's both for men and women. So it is becoming easier, but it's never going to be really easy because of the difficult challenge of time. A person has only so much time in their life. And so it does involve juggling your life schedule a little bit. It involves also a lot of collaboration and cooperation with your spouse and the other family members to make it happen. But it does happen, and there's a lot of success stories out there right now.
Absolutely. And I think maybe for a field like geology specifically, where you're traveling quite a bit, did you find this a challenge to have to balance your travel with your family life when you had young children?
I did. I was very fortunate to have a close family member that was able to take care of my children when I went away for, say, 2 or 3 weeks in the field, which is the big time problem, is to be able to go off and for 2 or 3 weeks or a month in the field. And she was very willing to take care of my children Of course, my husband was there as well, but he worked during the day. So this family support, at least in my case, was critical for me being able to pursue what I wanted to do.
Absolutely. Now, we've been talking about some of the challenges, Gail, and I think there are so many challenges that scientists face throughout the different phases of their career. Was there one in particular that you wanted to tell us about, maybe a story of a failure or a really frustrating situation, and maybe how you worked through that tough time?
Well, this is a tough question. Yes, I do have a failure. It's a little bit difficult to talk about, but it occurred when I was a professional, well into my professional career. I was part of an international interdisciplinary research team working in East Africa. And there were a number of graduate students that were included in this project. There were probably around 25 or maybe 30 of us in this big team working.
Yeah.
I was abruptly fired after I had been participating for about 6 years.
Oh, no.
Yes. And the firing came not in a face-to-face meeting, but in an email sent out to the 25 and 30 members of the team, including myself.
That's terrible.
Yeah, I was really shocked, and it took a while to recoil from it. I ultimately responded an email from my point of view, what I thought was unfair, but the firing remained. So it took me a couple of years, 1 or 2 years, to reorganize my research program and to get my head together, so to speak, and start sort of a new phase of the program in a different area and just to try to continue. So I'm not really sure how I could give any advice on how to deal with this, but it was a situation in which the politics or the personalities within this research team became a problem. I had female students with me who had been bullied in the field and had been treated poorly, and I had stuck up for them. And I think that was part of the problem of my firing. Mm-hmm. I also had some differences of opinion in terms of just the science. Straightforward, I had different views on some of the science that was being carried out. So the combination, I think, of the personality friction and the scientific confrontation was what set it off. But it was something that was pretty devastating to me as a person, and it took a while to move on.
Certainly. Well, Gail, thank you so much for sharing this challenging situation. I think this is sort of one of the worst scenarios you could imagine as a field biologist. You've got all these plans built up, all this work that you've invested over 6 years in this program, and all of a sudden for that to just be cut off. And I think that's not only challenging for you in that case, but you also have to think about these. You mentioned there was a group of 25, 30, including lots of students. So how did you manage the student involvement? Did they continue with the project, or did they kind of leave with you?
I had 2 students of my own. They were both women. One student was finishing up, and so she was able to complete her degree and carry on somewhere else. A second student, I had to give up. I had to turn over her supervision to someone else because I wasn't going to be allowed to go to the site, and I could not supervise her if I couldn't go to the site. So
Sure.
She was taken on by someone else and supervised for the rest of her degree. And actually, as a third person who happened to be an African, I was able to complete supervising his thesis. So 2 out of the 3 I was able to complete, and 1 I had to turn over.
Gotcha. Well, I think this is a really difficult situation. I think it highlights that science is not immune to these interpersonal conflicts, these political types of conflicts. And I think these things arise maybe in some unexpected situations as well. And you have to be aware of them, and you have to be prepared for them sometimes. So thank you for sharing this story, Gail. We don't just want to talk about the difficult points in your career, though. Next, I do want to talk about a success story, one of these high moments in your career where you did something. It could be just a small win, or maybe one of these huge victories that really meant a lot to you.
Yes, I do have a success. In fact, it happened relatively recently this year, and it is a study that I've been working on for about 4 years. The study involves the environment in which hominins were living, and the data that I collected was at Olduvai Gorge in Tanzania. And I was working on an archaeological site in which a very early hominin had been discovered over 50 years ago by Mary Leakey, who was one of the early investigators at Olduvai Gorge. And she discovered a couple of fossil remains of early hominins at a site. And for the last 50 years, the bones and the artifacts that had been uncovered at that site had been studied, evaluated, re-looked at, reanalyzed. And the reason for the archaeological site, the fact that it was where it was, always remained a mystery. They were never sure on why the site was there. It had several thousand bones, several thousand artifacts, and as I mentioned, 2 hominin fossil remains. So it was a very unusual exposure. It was called the Zinjanthropus site. I started to work on it a few years ago and analyzed the soil in which the sediments were found and did a collaborative study with a scientist named Clayton McGill, Pennsylvania State University, and it was part of his Ph.D. Mm-hmm. And he analyzed the organic matter in the soil and was able to determine that the site where the artifacts were found was in a thick woodland, so it was a woody area. But adjacent to the woody area was a freshwater spring and a very large, lush wetland. And he was able to reconstruct this from the organic matter that was in the sediment. And to make it even more amazing is that this record is about 2 million years old.
Oh, wow.
So to have the organic matter remain and to be analyzed after 2 million years was very impressive. So we published a paper recently in the Proceedings of the National Academy describing this human habitat, what it was like, and about the freshwater and the wetland, which contained ferns and a number of other plants that could have been eaten by humans. So we were able to come up with a context or a description of the environment of these hominins, the water they were drinking and the food they perhaps were eating as well.
Well, Gail, that is so cool. I can't even imagine being able to put together this picture of the environment 2 million years ago. So was there an aha moment where he started finding these bits in the sediment, or an exciting high point where you started being able to see these pieces fall together?
Yes, there was an aha moment. I had collected the sediments, I think around 4 or 5 years ago. And they did not look particularly organic rich to me, just from my eye, of course, without chemical analyses. Mm-hmm. And he inquired whether they would be able to look at them and analyze them. And I said, sure, go ahead. You can look at them. They're not very organic rich. I've seen organic sediments. I know what they look like. Uh-huh. So he took them back to Penn State. And then within 2 weeks, he said, oh, it's full of organic matter. So apparently it's just the amount of equipment. They have a very sophisticated lab at Penn State, and he was able to resolve in detail many of the organic molecules that had been preserved through time and was able to identify them as to what type of plants they represent in great detail, whether they were trees or shrubs or wetland plants or grasses. So we have been able to reconstruct an area about the size of a couple of football fields with the details of the plant cover and what the environment was like that humans were actually walking on. So it was a pretty exciting moment.
Well, that is amazing, Gail. Exciting success. Now, can you tell us a little bit about the Olduvai Gorge and maybe what it looks like now and what it's like working there?
Olduvai Gorge is visited every summer by thousands of tourists. They come to the edge of the gorge and they look down into it. From a view from the top, it looks like sort of a wasteland, a sand and gravel wasteland. You can see some outcrops, but there's a lot of just slope wash on the side. So it doesn't look terribly impressive physically. But once you get down into the gorge and are able to get up close to some of the exposures, one can see layers in the rock, and in those layers are where the artifacts have been uncovered, the fossils of vertebrates, the fossils of humans, and also the stone tools in which they used. And these are all within the sediment layers. In addition to those sediment layers, there are volcanic ashes, which are used to provide a date or the age of those layers.
Very, very cool. And I love this stark contrast that you're drawing, this lush foresty area of 2 million years ago now to this sort of wasteland of rock and the artifacts of the ancient civilizations there. That's so cool.
It takes a little bit of imagination, I think, sometimes, or maybe a little artistic creativity to take what looks like sand and gravel and dirt and dust, and out of it, of course, with the information from the geochemistry, able to flesh out, as you say, a lush and vibrant landscape.
Absolutely. So now, Gail, we've talked a little bit about this one project and the exciting success you had there, but is there another project you have going on right now that you're working on that you are so excited to share with us?
Well, yes, I do. It's an extension of this understanding of hominin environments that was mainly developed at the site at Old Levi Gorge. But the thought occurred to me that humans eventually migrated out of Africa, and they migrated out in a number of waves, starting at about 2 million years ago, about the time that we're talking about. And these hominins would have moved gradually northward up through the East African Rift Valley, up into Ethiopia and out by the Red Sea, perhaps, and cross into the Levant area. And eventually they made it into Eastern Europe, Georgia. And the tracing of their path out of Africa has always been a puzzle because Africa today is dry. It's been pretty dry in the past too, although the climate has fluctuated a bit. And so I had the thought that springs might have been, and these groundwater sources might have been a means of supporting life or supporting people as they gradually moved northward out of Africa. And so I've been working with some other colleagues to try to assess this as a possibility of having springs in these former times available for water so that hominins could move step by step, like leapfrogging up through the Rift Valley and out of Africa and into Europe using these freshwater sources. So that's what I'm working on right now.
Well, that is so cool. So how do you track or trace where these sources were, and how do you know where to look?
A good question, as they say. The current position of springs gives us a hint. There are some modern springs right now. We are in a very dry period in East African climate. Now in 2000 mark, it's quite dry there. But there are still springs. There are swamps and springs available for some modern animals and also people. They are found commonly at the bottom of the slopes or the base of the valleys in the bottom of the Rift Valley, where groundwater seeps out at the bottom. But they're very localized. And so we know they exist now, and it's quite likely that they existed in similar positions in the past. And the way to assess that, of course, is to look at the geological records from these ancient deposits. And so I have done some of that. I've worked in Kenya at a number of places and gradually putting together a compilation of geological records of springs.
Well, this is phenomenal work, Gail. I love how you use geology to recreate the picture of history of so many years ago. I think that is really, really interesting science. Now, Gail, I know it can be a challenge to escape from the research, from the scientific literature for a little while, but I love chatting with scientists about what books they're reading for fun. So can you share with us today one of your favorite books that you've read? And it can be a science book or a non-science book.
Actually, my favorite book is on Africa, and it's called West with the Night by Beryl Markham, who was a woman pilot and then, I guess, adventurer that lived in Kenya during the early 1900s. She was one of the first pilots, first women pilots anyway, and a very remarkable woman who followed her heart and did what she loved best and was very good at it. It's a really good book to read. It's very inspiring, but it's also well written.
Well, phenomenal recommendation, Gail. We will put that out on our reading list for our listeners if they're in search of their next good book. And now we've talked about some of the places that you've been for your science, specifically some of these locations in East Africa. And I love chatting with scientists about these phenomenal travel opportunities that they have in their career and to hear about some of the exciting places they've been. So, Gail, can you share with us today your favorite travel destination for science?
Oddly enough, Africa is second.
Really?
Yes, I know. It doesn't seem quite right, given that I've been working there for 20 years. But I actually liked the Brooks Range in Alaska. I spent several summers there in the Brooks Range, which is in very northern Alaska. It's a small mountain range at the very northern part, and then as you continue north, you go down the north slope into the sea. I spent several summers there working on the sedimentology there, and there were some records of early humans into North America there. And I was working on the geology as part of a trip there. We were brought in by airplanes, small planes, and left there with boats to travel down rivers and stop along the rivers and look at outcrops and gradually put our data together and the story together on what we were seeing. So that was my favorite spot because it is mostly undeveloped. There are just a few Native Americans that travel to the area for hunting, but it's pretty well a pristine and untouched landscape with wildlife. I saw wolf and muskox and a number of other animals, which was really exciting to see in their natural state.
Absolutely. Well, it sounds phenomenal. So going to this relatively pristine, undeveloped place, did you have any concerns? I guess I'm maybe not the rough and tumble field biologist myself, but are there some challenges working in a place like Alaska where you have to be prepared for unexpected circumstances or to really make it in the wild?
Actually, yes. I was a little apprehensive because most of our travel was on rivers and the water was very cold. Mm-hmm. I was always worried about the boat tipping over, but as it turned out, it didn't. And we did survive quite well until the very end when the planned pickup that we had by airplane was delayed by 3 days or 4 days. And the problem was that the plane was being repaired and they couldn't get parts. And the pilot was tied up, was not able to get another plane to come and get us. And so we were left at our pickup spot for 3 or 4 days with, as it turns out, no food.
Oh, no.
No food. We hadn't planned to have leftovers.
Right. You were rationing appropriately.
We were rationing and we had to hand carry everything. So we ended up doing a little fishing. We actually got some fish and were able to cook that. And we found a few candy bars in the bottom of a pack, and that was it. And I realized what it was like to not to have food for 4 days. And it was an interesting experience.
Oh, I would have been a mess. I know I get hangry if I haven't eaten in a couple hours. So very admirable that you were able to make it through this tough time.
We were glad to see the pilot.
Absolutely. Well, now, Gail, we've talked about some of the exciting travel that you've done, and you mentioned a couple of places. So Alaska, absolutely. Africa, phenomenal. But I understand you've also been to a lot of other places. You've been to Antarctica, Ireland. Can you tell us a little bit about what it's been like working in all these very different environments for your work?
Well, I'll start with Ireland. It was an experience in terms of the culture. We often had to get permission from the locals to get on their property. And so I got to know many of the farmers. And this was prior to the time when they joined the European community. So they were still fairly rural and unconnected with the bigger economic pictures. And the exposures that I was able to look at were fantastic in Ireland because of the lack of vegetation. If you've been to Ireland, you know that many of the trees were cut down and used for either building boats or matchsticks or whatever they were used for.
Sure.
There is very little vegetation on the landscape, and so one can see what the topography looks like very easily. And so from a geomorphologist point of view, it's a fantastic place to work. I enjoyed the landscape and also the culture there.
Definitely. And I know the work in Antarctica was sort of a long time coming. You were interested in working there, but weren't able to initially. And then you were finally able to do some work there. Can you tell us about what that was like?
Yes, I was able to go to Antarctica first on a couple of cruises. I was invited to go on some cruises with other scientists that had grants to go there. And so I was first exposed to Antarctica by scientific cruise ships, which is a very different way of collecting data. It's quite remote. You're on a ship and you collect data over the side. It's important type of data to collect, but I like to be close up and personal with what I'm working on. Mm-hmm. So I wrote my own proposal to go and work on a glacier to try to understand about the sediments and the geological record that's produced by melting glaciers. And I was lucky to be funded. So I went, took 2 students with me and another colleague, and we went and spent 2 months at Palmer Station in the peninsula area of Antarctica and worked out of Zodiacs, small motorboats in could have been dangerous conditions, although we tried to stay out of dangerous conditions.
Sure.
But we were working on a glacier, and the glacier was calving. Calving means these large blocks break off.
Do you know when it's coming? Is it making the sounds or something to alert you?
Yes, it makes a cracking sound, okay. And you can hear it coming, but if you're up nearby...
There's not much you can do, yeah.
And I did have one scary event in which we weren't expecting any calving because the calving tended to occur at certain times of the day, and we avoided those times.
Gotcha.
But we were in the boat collecting data over the side and sampling. And I heard this crack and looked around, and there was this huge, big chunk of ice coming off of the ice front. So we turned the boat around 180 degrees, but didn't quite outrun the standing wave, which eventually came through, but we were able to ride over it. But it was a very scary event.
Oh, that sounds terrifying, Gail. I must say, you have painted quite an adventurous picture of the life of a geologist. I love it. And in hearing about some of your work in these different places that you've been, you've mentioned different colleagues, and I know you have collaborators and colleagues all over the world. And I think when you put this many bright, brilliant people together on a team, crazy things happen. So there's fun traditions that spring up, or even just hilarious or fond memories that you have with these people. So Gail, can you share a story of your own of the human side of science, or just a memory or an experience that you shared with people that maybe contradicts some of the stereotypes people have about scientists out there?
Well, I don't know if this story exactly fits that. But this is in Africa, and I was working with some paleoanthropologists there, and we were doing a survey, which means we're walking around, and this was at Olduvai Gorge, looking for some outcrops, looking for some geological exposures that we hoped would have some evidence of artifacts or bones coming from them. So we were walking along, looking at the outcrops, and I came around a corner and came up against what was a small herd of elephants. And we had no idea they were there. I hadn't heard they were there. And they turned out to be about maybe 50 yards from us.
Wow.
And so I looked at my colleague who had had more experience with this, and I said, what do we do? Mm-hmm. Of course, I had thought about, let's climb a tree. Right. But I wasn't going to be able to do that. There were no trees anyway, and I wasn't sure if I was supposed to run or not.
You're like, quietly sneak away? Yeah, what do you do?
He said, let's just back up slowly. So we backed up very slowly, and as it turned out, the elephants didn't care about us, but we backed out of their sight. So I don't know whether that's funny or not, but it was just something that happened that gave me a whole new respect for what kind of dangers and what hominins might have experienced when they were living on the landscape, occupying the same space as some of these large animals.
That is a phenomenal story. I love the idea that you were snuck up on an entire herd of elephants without knowing it. Very cool. And I think this is part of the unexpected aspects of fieldwork. We've mentioned a couple different situations where you never really know what's going to happen out there. And I think it is really interesting to think about people living in that time, in those early days, all the different unexpected encounters that they would have and how they had to shape their lives. So very cool parallel you drew there. And now we've talked about some of the research that you've done over the years, some of the projects you're working on now. But Gail, one question that I love to ask scientists is, what do they still want to know? What is the big question out there that you are still chasing? So can you tell us, if we gave you everything, funding, staff, technology, feasibility, none of these things are barriers. Gail, what is the one thing that you would want to answer?
Well, because my research is focused on hominin records right now, it's been that way for the last 20 years. And my interest is in water, the role of water in their survival, and also the geological controls on where water occurs in this natural environment. As I mentioned before, East Africa is dry, and in most places it's arid to semi-arid. And so the water supply is pretty tenuous. Most lakes are salty, and many streams dry up in the dry period. And so the one source of water are these groundwater sources. At the moment, I am being driven to try to understand better the geological controls on the groundwater, where water is recharged. And we suspect it's in the high areas, topographically nearby high areas, and that the water moves through the subsurface and comes out at the bottom. That's kind of a simple model. Geology is never simple, and no two places are alike. So I'm trying to work on the problem of understanding the geological controls. And I started to work with people who do computer modeling that can help model what happens to water over long periods of time, and all the practical things we need to know, which are the flow rates and the time involved in groundwater movement. That's the thing that I would like to know.
Certainly. And I really like the point you brought up of geology is never simple. I think the story in science is never as simple as it initially appears, or as you can even build in your models that you're putting together. So now, can you tell us, though, what is a potential example of some of these geological controls, just to give us an idea of the sort of pieces that you're fitting together here?
Well, the area that I've been describing is the East African Rift Valley. And it's an area which is geologically controlled by tectonics. It's being pulled apart The crust is being yanked apart, as it were, and a large valley produced in the middle, and there are faults following this valley. And it's an extensive feature that goes all the way from Malawi, which is south of the equator, about 1,000 miles way into Ethiopia and up into the Levant area of Israel and so on. And so it's an enormous feature which can be traced on maps and by satellite imagery. And it's a major feature. And that is controlling where the groundwater is. And also the topography, the high areas and the low areas that are created by volcanoes. We have a large number of volcanoes in the area. And so this complex topography, relief, and the deep valleys are the geological setting of it. So in order to understand what the groundwater is doing, we have to be able to determine about groundwater flow in this complex geological area.
Well, very interesting. Well, Gail, great to hear more about these big questions on your mind. And I think as you're going through your research, pursuing these questions, there are a lot of collaborators that you work with, as we mentioned, a lot of mentors and role models along your journey that help you. And these people are great sources of advice. And advice is something we love to pass on to our listeners in this show. So, Gail, can you think back along your career? And is there one piece of advice that really sticks out in your mind as the best advice you've ever received?
One bit of advice that was really important to me, I don't know if it was the best advice or not, but it was by a colleague who was giving me advice when I was in a crux, trying to decide, I think, about perhaps going on to graduate school. It might have happened that long ago. And I was a person who had been gradually building confidence over the years, from the moment that I discovered science in 8th grade till about today, continually building confidence in what I could do or what I couldn't do, which is probably more important. And this advice that my friend gave me, or colleague gave me, he said, Gail, you make good decisions. Go with them. And it really struck me because I actually hadn't thought of myself as making good decisions. But he said, you do. Go with it. Go with your decisions. So I don't know if that's advice, but it kind of gave me a boost anyway into following what I could do and trust myself a little more.
Well, that is fantastic advice. And I know confidence is something that notoriously scientists struggle with. And I think having someone there to tell you, don't worry, you're making good decisions. Just follow your heart, follow your mind, just go with it. I think that is critical. So listeners, keep that in mind. If you are at a crossroads, go with your gut sometimes. Just accept that you are making good decisions and everything's going to be okay. So now, Gail, is there any other last piece of advice or maybe one last note of inspiration that you want to leave us with today?
Well, I guess I would just reiterate what you said. The advice that I give students now, I'm the undergraduate director at the geology program, so I advise our majors when they're thinking about careers, and I tell them to follow their interests. Sometimes those interests are contrary to what their parents would like them to do, so they are conflicted about what they should do. I think that if you try to follow your interests, you may not be able to land a job immediately in what you want to do. In fact, in situations like mine, I was circumvented for at least 6 or 7 years with my early family. But I always thought that eventually I would get back to it. And your family situation or your personal situation may get in the way. But if you have a long-term view and realizing that people live a long time these days, live into 80s and 90s and can have good, healthy lives. And so making a decision when you're 20 or 22 or 25 and even 35 is not that big a deal. I think you have to be patient, but if you keep your eye on the prize and just work toward that, that's best to end up a happier person, I think, if you can follow your passion.
Well, Gail, excellent advice for our listeners out there. Listeners, definitely follow your interests, follow what you're passionate about, and don't let anyone tell you it's too late to follow those passions. I think, Gail, you are a perfect example of that, working out really, really well, where you went back to school to get your Ph.D. a little bit later, and you've had a fantastic career as a geologist. So thank you so much for sharing your stories with us today. Can you tell our listeners now where they can go if they want to learn more, how they can get in touch with you?
The best way to get in touch with me is my email address, which is gmasley@rci.rutgers.edu.
Perfect. Well, listeners, definitely reach out to Gail if you have questions or if you want to chat with her more. Gail, thank you so much for your time today and for joining us. We really appreciate all your insights.
You're very welcome.
And listeners, thank you for joining us today. We'll see you next time on another episode of People Behind the Science. Your voyage to explore the lives of today's exceptional scientists has just begun. You can find everything we talked about today, including our guests' favorite books, biographies, photos, and more, when you visit us at www.peoplebehindthescience.com. I look forward to chatting with you next time on People Behind the Science.